Alright, today we'll be talking about area of a triangle, but before we begin, we have to start by discussing what area is. And area is the number of 1 by 1 units in a given shape. So here we can see that we have a rectangle with W rows, each with L columns in them. For an example of this, we can use this rectangle, which we have W equals 3, L equals 4, and you can see that there are 12 1 by 1 squares. So this proves that if you take W times L, which is 3 times 4, you get 12. Okay, before we begin discussing whether or not 1/2 base times height is the correct formula to use when finding the area of a triangle, we need to discuss the 3 types of triangles you can use for this. The first type of triangle is where the height is on the side of a right triangle. So here. The second triangle is where the height is on the inside of the triangle, and then the third is when the height is on the outside of the triangle. Okay, for the first type of triangle where the height is on the side, we see that we have the base down here and the height up here. We need to find the area of this triangle, so to do that, I duplicated this triangle and rotated it around to right here. Now you can see that we have a rectangle where we already know that you can take width times length to get the area of a rectangle. So essentially the width of this rectangle is the height and the length is the base right here. And we can see that the triangle we are trying to get the area of is half of the large rectangle. So that would be 1/2 length times width, also known as 1/2 base times height. Okay, the second triangle is where the height is on the inside, and we essentially do the same exact thing as the last triangle. We duplicate this half and rotate it around up here. We duplicate this half of the triangle, rotate it up around here, and make a large rectangle. We can see that because we duplicated both of these sides, that they would be 1/2 of the whole rectangle that we created. So again, this rectangle, or this triangle, excuse me, would be 1/2 base times height to find the area. Alright, the final triangle is the trickiest. It's where the height is on the outside. So right now you can see that this extension that we added on where the height is, I put X to symbolize this extension from the base of the original triangle. Height is over here. So what we want to do is get the area of this triangle, excuse me again, triangle. But in order to do that, we also need to find the area of the larger triangle, which includes this area right here marked in green. So to do that, we have to find the area of the whole big triangle and subtract this area from the big triangle to find the area of this triangle. So, what we need to do, we have the big right triangle right here, which from the very first proving where height is on the outside, we know that 1/2 base times height gives you the area. So for the big right triangle, we have the base as b plus x, if you can see that, times height. So it would be 1/2 base times height. We need to subtract the small triangle right here, which is 1/2 x times h, because it's a right triangle again, and we proved that 1/2 base times height works for that. So right now we have 1/2 base times b plus x times h for the large triangle, and then 1/2 x times h for the small right triangle. In order to find the area of the triangle we want, the one in purple, we have to subtract the small triangle from the big triangle. So we have 1/2 b plus x times h which is the big triangle, minus 1/2 x times h. We are going to distribute the 1/2 over for the large triangle equation. So then we get 1/2 b times h plus 1/2 x times h. Subtract the small area equation, which is 1/2 x times h. Once that is done, we can see that these two 1/2 x times h's cancel out, and it leaves us with 1/2 base times height. So we have proved that all three triangles work for 1/2 base times height.